In this lesson, we're going to take a look at rationalizing denominators that have binomials involving radicals in the denominator, as opposed to the single radicals that we looked at in the previous lesson. We're going to be using something called conjugate pairs in order to rationalize these particular fractions. A conjugate pair is when two binomials have everything matching except that one is a positive and one is a negative. The reason why these are special is because if you think of all the factoring work that we have done in the past, this is the result that we get when we factor the difference of perfect squares. So we can actually simplify the process by simply multiplying the first two values together and then multiplying the last values together in each one in order to come up with what our result will be when we multiply two conjugate pairs. We know that the middle terms are going to cancel out, and we saw examples of this in the previous lesson. This means that when we go through to rationalize these, we can shortcut the multiplication process in the denominator by multiplying just the first parts of each parenthesis times and then the last parts of each parenthesis. Let's look at an example so we can see exactly what we need to do. In the first problem, we have 1 over 3 minus radical 7. The conjugate pair for this particular example will be the exact same binomial, but changed to a positive instead, so it's 3 plus radical 7. However, again, if I'm going to multiply the denominator by 3 plus radical 7, I also have to multiply the numerator by the exact same binomial. In the denominator, we're going to take the first part of each binomial, multiply those together. 3 times 3 will give us 9. We have a negative radical 7 and a positive radical 7. We multiply the last parts together. Negative times positive is negative, and radical 7 times radical 7 is radical 49. In the numerator, I have to go ahead and take the 1 and distribute that among both parts of the binomial here. Obviously, if we're multiplying by 1, it doesn't change the value, so we're simply left with 3 plus radical 7 on top. We do need to simplify this problem down. To do that, we can take the denominator. We know that the square root of 49 is really 7, and so 9 minus 7 is going to give me a 2. On top, I'm still left with 3 plus radical 7. Since neither the 3 or the radical 7 has an even number in the front parts of it, there's nothing that I can divide both the terms by 2. Therefore, this is as simplified as this problem is going to get. If I was able to divide anything by 2, I should split this up and divide each part in order to simplify it down further. In many cases, this will be as far as you need to go. Let's take a look at the second example. Since my denominator has 1 plus radical 3, that means my conjugate pair is going to be 1 plus radical 3 and 1 minus radical 3. I also need to multiply the numerator by the conjugate as well. I am now going to multiply. Let's take care of the numerator first this time. Multiply both parts by 3. We get 3 minus 3 radical 3 when that's distributed through. In the denominator, I multiply the first parts. 1 times 1 is 1. Minus, and then radical 3 times radical 3 is radical 9. The square root of 9, of course, is 3. So that means that when I do this part over here, 1 minus 3 will give me a negative 2 on the denominator. And I'm still left with 3 minus 3 radical 3 on top. The one thing we have to be cautious with this problem is that we're often not going to leave a negative in the denominator for our final answer. So the negative will be written out in front, and it'd be 3 minus 3 radical 3 over 2. The other possibility, and the reason why I want to show this to you is in case a question does this to you, is it could possibly take that negative and distribute it inside. If you left the answer the way it was, it would be fine, but the other way you could see this answer represented is negative 3 plus 3 radical 3 if that negative is distributed, and then over the positive 2. Scrolling down, we have a couple more examples to take a look at. This time in example number 3, the radical came first, but we're not going to be changing what we're going to be doing for this problem. So again, we're going to figure out what the conjugate is to the denominator. If we have radical 7 plus 2, then that means our conjugate must be radical 7 minus 2. And we're going to multiply these binomials together. And if I'm going to multiply this bottom part by radical 7 minus 2, I need to also multiply the top. If I distribute the 9, I get 9 radical 7 minus 18. On the bottom, I'm going to multiply the first part, so that's radical 49. And positive 2 times negative 2 is negative 4. The square root of 49 is 7. So 7 minus 4 will leave me a 3 with the bottom. And the top part is still 9 radical 7 minus 18. And you might notice in this particular problem that the 9 and the 18 can both divide by 3. So I am going to split this one up into 9 radical 7 over 3 minus 18 over 3. And I can actually divide these out. So 9 divided by 3 is simply 3. So this is 3 radical 7 in the first part. And 18 divided by 3 will give me a 6. So 3 radical 7 minus 6 is the most simplified answer for this problem. Let's take a look at one more example. Example number 4. My original denominator is 3 minus radical 3. So the conjugate is going to be 3 plus the square root of 3. And again, if I multiply that on the bottom, I need to also multiply the top by the same thing in order to keep this balanced. You'll notice I have a radical in the numerator, so I do need to be a little bit more careful with my distribution here. So we're going to get 3 times radical 3 when the radical 3 is multiplied through, plus, and then radical 3 times radical 3 is radical 9. We'll clean that up later. On the bottom, we multiply the first parts. 3 times 3 is 9. Minus, and then radical 3, or negative radical 3 times radical 3 will give us negative radical 9. Now, one thing that you have to be cautious about is do not just cross off the radical 9s here. We are locked in with plus and minus signs on the top and bottom respectively, so we don't want to just cancel them out. We can simplify a bit, though. The square root of 9, of course, is 3, so that means in the denominator for this problem, I will have a 6, and it's 3 radical 3, and then I can also change my radical 9 on the top to a 3. And then let's bring this down here. I'm going to split this up into 2 different fractions. I notice I have a 3 over 6 really in both of them. 3 over 6 reduces to 1/2. So what we will end up with here is 1 radical 3 over 2 plus 1 over 2. which technically you can leave, but they might ask you to simplify this and leave it in one fraction. Therefore, what we should do then is in the numerator, it's radical 3 plus 1 or 1 plus radical 3. Make sure the 1 is clearly not in the radical. And the whole thing is over 2. Since they have a common denominator, I can put those together as one fraction.